In this video, we will introduce the product rule. All right, so the rule says if f and g are differentiable functions, then the derivative, d dx, the derivative of f of x times g of x, the product of two functions, will be equal to f of x times the derivative of g of x plus g of x times the derivative of f of x. And if I wanted to write these derivatives with the prime notation, so like write g prime of x here and then f prime of x there, that would be just fine. Okay, so this is the rule, and I want to give a memory trick for this. So the way that I remember this is I have the derivative, and I call these two functions the first function and then the second function. So the derivative of first times second is the first times the derivative of the second plus the second, and then you sort of switch it, plus the second times the derivative of the first. So I would encourage you to pause the video, quick pause, like a 15-second pause, and just like chant the memory trick a few times. So I'll do it once all together, just me here. So the derivative of first times second is first times the derivative of the second plus the second times the derivative of the first. One more time, it's the first times the derivative of the second plus the second times the derivative of the first. I'd encourage you to do that at least 2 more times, that chant. Alrighty, so let's get into some examples. So I'm not going to prove the product rule. We could do it using the limit definition of the derivative. I want to focus our time more on applying it and doing some examples. So let's let a of x be cube root of x times e to the x. Part A says find the first derivative of a. Part B says find the second derivative of a. Okay, so let's get the derivative of this. So I have these two functions multiplied, so let's use the product rule. We are going to need to take the derivative of cube root of x, and just to prep, it's going to be helpful to rewrite the cube root of x as x to the 1/3, and then times e to the x. So now we want to do the product rule. So we want to do the product rule. So the product rule says, well, you'll have the first function, x to the 1/3, times the derivative of the second. So times the derivative of the second. I'm going to try to write all my derivatives in green. And then plus the second function, e to the x, times the derivative of the first. So times the derivative of the first, x to the 1/3. All right, and now let's evaluate these derivatives. So we get x to the 1/3 times the derivative of e to the x is just e to the x. And then I get plus e to the x times the derivative of x to the 1/3. I need power rule here. The 1/3 comes down. And then I get x to the, subtract 1 from the power, and I get negative 2/3. And that's my derivative. At this point, I've finished doing the product rule. I've computed these other two derivatives that showed up when doing it. Okay, so I'm going to box this and leave this as my answer. Let me continue to write a prime of x, a prime of x. That is my first derivative. It's okay if I don't simplify it. Now I need the second derivative. And for the second derivative, it will help a little bit if I simplify now. So I realize there's an e to the x in both of these terms. We can factor that out. So we get a prime of x. Let's factor out that e to the x. That leaves me with x to the 1/3 from the first term. From the second term, it leaves me with plus 1/3 x to the negative 2/3. And that's going to be helpful now because when I take the derivative again, when I do the derivative of this, which is the second derivative of a, what I am dealing with is e to the x times some function. That's going to be product rule. I'm going to need product rule again. But if I had done that on the previous step, if I had done it here, if I look at x to the 1/3 times e to the x, well, that's my original function. That would need product rule. And then if I look at e to the x, and then times 1/3 x to the negative 2/3, that's a product of two functions. I would need product rule for that also. So if I had just dove into the derivative here, it's not wrong, but I would just have to do product rule twice. So simplifying it a little bit, it's going to let me be more efficient. Okay, so product rule. We need the first function, e to the x, times the derivative of the second. Let's switch colors. So times the derivative of the second. Derivative of x to the 1/3 plus 1/3 x to the negative 2/3. And then plus the second. So plus x to the 1/3 plus 1/3 x to the negative 2/3. That's the second. And then times the derivative of the first. So times the derivative of e to the x. All right, so we have a double prime of x equals e to the x. Now for this derivative, this is a bunch of product rule. For x to the 1/3, I'll get 1/3 x to the negative 2/3. For the next term, the negative 2/3 comes down. It multiplies the 1/3 to get negative 2/9. And then I subtract 1 from the power to get x to the negative 5/3. All right, and then I have plus this x to the 1/3 plus 1/3 x to the negative 2/3. And then times the derivative of e to the x, which is just, it's just itself. All right, so we have finished that application of the product rule, and that is my second derivative. I don't need to simplify it, so it's okay to leave it like this. I just simplified the first derivative a little bit, so it made doing the second derivative a little bit easier. Okay, let's look at another example. All right, example 2. b of x is the 4th root of x times 4x squared minus 1 over x. And the question says define b prime of x. All right, so I want to first just have you do a quick pause and think about this for 1 minute and see if you can find the most efficient way to approach this. Would it be the best way? Would the best way be product rule or not to use product rule? 4, 3, 2, 1, pause it and think about that for a minute. Okay, so let's talk about it together. I want to start with a note, and the note is that sometimes we can simplify first and avoid a more complicated rule, like in this case product rule. Sometimes we can avoid product rule. In the next video we'll learn about quotient rule, and sometimes we'll be able to simplify things to avoid quotient rule. So I can do that if I recognize square root of x, that's x to the 1/4. And now if I distribute the x to the 1/4 into these terms, we'll get b of x equals, I'll get 4, and then x, I have to add 2 to 1/4, which will give me 9/4. And then I'll get minus, let's also rewrite the 1 over x as x to the negative 1. Because when I add negative 1 to the 1/4, I'll get x to the, let's see, I'll get x to the negative 3/4. So I've rewritten it. Now we're ready to take the derivative, b prime of x. So at the step where I take the derivative, I need to indicate that in my notation with something like this, b prime of x. So this is going to be power rule. The 9/4 is going to come down. So when I do 4 times 9 over 4, that'll leave me with just 9, because the 4's will cancel. And then I'll get x to the 5 over 4 after I subtract 1 from the exponent. Then the negative 3/4 will come down and multiply that negative 1 to give me plus 3/4. And then x to the, when I subtract 1 from this power, we get negative 7/4. And this overall ends up being quicker than if I were to do it using the product rule. So let me box this as my answer. If we wanted to use the product rule and use x to the 1/4 as the first function, and then 4x squared minus 1 over x as the second function, it's not wrong. It just would be a little bit longer. And it's helpful to know different approaches so we can decide which approach is going to be most efficient. All right, so in terms of our goals, we have finished the first part of this goal, which is talking about when and how we apply the product rule.